So in this presentation we have to talk about group multiplication table. Suppose a group contains n elements and the possible n square multiplications of these elements are presented in a table called multiplication table or Cayley table. Cayley is the name of a mathematician who introduced the concept group multiplication to the universe. While constructing the group multiplication table, we have to follow certain rules. The first rule is the group multiplication table should be of order n by n. Suppose n elements are present in the group, the multiplication table should contain n rows and n columns. The second rule is each row and column should contain all the elements. And the final rule is no element should be repeated in a row or a column, which means that duplication is not admissible in a row or a column. With the help of these three rules, now we have to construct a multiplication table for the given group of order 3. That is G equal to EAB. E is a unitary element. A and B are other two elements. Now write down all the elements in a row as well as in a column and make the multiplication. E into E equal to E. E into A is equal to A. E into B equal to B. Because E is an identity element, the product of identity element into any element is equal to that element. In this way, the first row is filled. In the same manner, the first column is also filled. E into E equal to E. A into E is equal to A. Then B into E equal to B. Now we have to fill up the rest of the four elements. What are the values of A dot A and A dot B? If you find out the values of A dot A and A dot B, you can fill up the second row, and if you find the values of B dot A and B dot B, we can finish our third row. Now to fill up the second row, we have to find out the value of A dot A and A dot B. Then in the given group, the elements are E, A, B. So the element A is available here. So these two terms should contain the rest of the elements E and B. So the value of A dot A may be E or B. Consider the first probability A dot A equal to E. Say A dot A is E. Automatically the value of A dot B equal to B, because a row or a column should contain all the elements. If I write A dot A equal to E, automatically we have to write the value of A dot B equal to B. If I fill this row in this consideration, a difficulty is arose in the third column because B is occurring in two times. Duplication is occurred. According to the third rule, no element should be repeated in a row or a column. So this option is not correct. This is wrong. A dot A is not equal to E. So the next option is the value of A dot A is equal to B. If you take this option A dot A equal to B, automatically the value of A dot B equal to E, because a row or a column should contain all the elements of a group. If A and B are present, the rest of the element is E. So spontaneously we can write the value of A dot B equal to E. In this way, we have filled the second row also. Now we have to fill the third row. B dot E equal to B. Now we have to find out the values of B dot A and B dot B. Then B dot A is filled in two ways. First option is B dot A equal to A. So here B dot A is equal to A. If B dot A equal to A, the value of B dot B could be E, because a row should contain all the elements of a group. Already the elements B and A are existing, so the left out element is E. So spontaneously we can write B dot B equal to E. By the way of considering B dot A equal to A, if I develop the third row, a difficulty is arose, because In this consideration, the third column contains 2 times E. A repetition is present in the third column, which is not acceptable one. So this option B dot A equal to A is not acceptable one. Therefore, we have to go for the next probability, B dot A equal to E. If you write B dot A equal to E, automatically the value of B dot B equal to A, because a row or a column should contain all the elements of a group. In this way, we have filled this multiplication table. See here, the value of A dot A is B. If I write B here, automatically A dot A is equal to B. Automatically in this row the left out element is E, because a row or a column should contain all the elements of a group. E, A, B are the elements. A is present, B is present, so the left out element is E. Now we have to fill up these two columns in the easiest aspect. A and B are present, so here E should come. Here B and E are present, so automatically we have to write A here. Now see, all the three rows, all the rows are having all the elements of the group. The same logic is true for all the columns also. Without repetition, all the elements are present in each and every row and column. Furthermore, if you see this multiplication table, you may find out that a symmetry is present along the diagonal. Say the diagonal elements are the elements of the group. So this group is abelian as well as cyclic. Say that the condition for a cyclic group is A square, A cube is equal to E. This is the condition for a cyclic group. Here the elements are, only 3 elements are present, so that I have written A square, A cube equal to E. Now the given group is G equal to A comma B comma E. This is a given group. Here the first element is A. Instead of B we have to write A square, because A square is equal to A dot A. What is the value of A dot A here? A dot A equal to B. So the second element is A square is equal to B. Then third element is A cube. A cube is equal to A square into A. Then the value of A square is A dot A, that is equal to B dot A. So A cube equal to B dot A. What is the value of B dot A? See here, B dot A equal to E. This is E. So the given group G equal to A comma B comma E is written as A comma A square comma A cube is equal to E. So the given group is cyclic of order 3. At the same time, all the cyclic groups are abelian in nature. If you say a group is abelian, the elements of the groups are subjected for commutation relation. In this group also, the elements are subjected for commutation, which means that AB is equal to BA. See here, the value of AB, A into B is equal to E. Then B into A is also E. So AB equal to BA. The same logic is true for all other cases. A into E equal to E into A. Then B into E equal to E into B. Therefore, the given group G equal to E, A, B is cyclic and abelian.